Dear students, having explained discrete random variable and the probability distribution of discrete random variable, now we consider some of the widely used discrete random variables. We start with Bernoulli random variable. We start with Bernoulli random variable, introduced by Jacob Bernoulli. Jacob Bernoulli. Now, the distribution of a Bernoulli random variable x is like this: x f of x. X takes the values 1 with the probability p, 0 with the probability 1 minus p. Now, the distribution of a Bernoulli random variable x is x is equal to 1 with the probability p, and x is equal to 0 with the probability 1 minus p. And x is equal to 1 is called a success. X is equal to 0 is called a failure. X is equal to 1 is called a success. X is equal to 0 is called a failure. So x is said to be a Bernoulli random variable if its PDF is given like this: x takes the values 1 and 0 with fx p and 1 minus p. X is equal to 1 is known as success, 0 is failure. Now, expected value of x is 1 into p plus 0 into 1 minus p is equal to p. So, expected value of x, that is mathematical expectation of a Bernoulli random variable, is p. Now, expected x square can be written as 1 square into p plus 0 square into 1 minus p is equal to p itself. So, variance of x is expected value of x minus expected value of x the whole square. We can write a variance of x as equal to expected value of x minus, expected value of x square minus expected value of x the whole square. That is, and what is expected x square? P minus what is expected x to the whole square? P square. So, variance of x can be written as p into 1 minus p. So, if x is a Bernoulli random variable, its expected value is p, variance is p into 1 minus p. Often 1 minus p is denoted by the symbol q, so that variance of x can be written as p into q. Variance of x can be written as p into q. So, if x is a Bernoulli random variable with the probability of success is equal to 1. Probability of success is equal to P. Failure is equal to 1 minus P. We write it as X is distributed as Bernoulli with X is distributed as Bernoulli with P. So we denote a Bernoulli random variable using this notation. Expected X is P, variance is. So it has two outcomes, 1 and 0, with the probability of 1 success, P, failure, 1 minus P. As an example, suppose that an operator is using a lathe to produce pins. An operator is using lathe to produce pins. Since the lathe is not perfect, the machine always will not produce good pins. It has a probability P that the machine will produce, the lathe will produce a good pin, and the probability 1 minus P that it will produce a defective pin. So we denote X as equal to 1 if the lathe produces a good pin, X as equal to 0 if the lathe produces a defective pin. So X follows Bernoulli distribution. Now, if the outcome, we generalize it. If the outcome of a trial can only be either a success or a failure, then the trial is known as Bernoulli trial. If the outcome of a trial is either a success or a failure, then the trial is known as Bernoulli trial. And the number of success in a Bernoulli trial, which can be 1 or 0, is known as a Bernoulli random variable. The number of successes in one Bernoulli trial, remember one Bernoulli trial, which can be 1 or 0, is known as a Bernoulli random variable. Another example, suppose that you toss a coin, and if a head turns up, let it be success, give the value 1. If a tail turns up, let it be 0, it is a failure. Then the outcome of a toss is a Bernoulli random variable. The outcome of the toss of a coin, either 1 or 0, is a Bernoulli random variable. Now the Bernoulli random variable is too simple to have any immediate practical use. But Bernoulli random variable is the building block of what is known as binomial random variable. Which has considerable practical use. So now our next concern is binomial random variable. In the next class we discuss binomial random variable.